Hey everyone, in this video we're going to be looking at how to factor quadratic trinomials, and once we learn how to do that we're going to use it in an application to solve certain quadratic equations like number 7 and number 8 here. So let's go ahead and take a look at number 1. So for number 1 we have a quadratic trinomial. Now quadratic trinomials come in the form of ax squared plus bx plus c. Okay, we have three pieces here, ax squared, bx, and c. So it's going to be a trinomial, and these are called quadratics because the highest degree variable is, the highest degree of the variables here is 2. Now, when you think about something being to the second power, you say it's being squared, right? Well, a square has 4 sides, thus where the name quadratic comes from. So this is a quadratic trinomial. Now, number 1 here certainly fits the bill of a quadratic trinomial, right? We have x squared plus 8x plus 12. This is written in something called descending order, where your highest degree variable is written first, followed by your second highest degree variable, and then we have our constant term on the end. In this case, our a would be the coefficient 1, b is the coefficient of x, which in this case is 8, and c is our constant number 12. Now, if we want to factor this, we want to change this into an expression where we have 2 or more things being multiplied together to obtain this original statement here. So we want to, instead of writing it like this, we want to write this as a multiplication between some terms. So in order to do this, we're going to take a look at our c term. Now, no matter how this is written, we're going to take a look at the c term here. Now, this is a shortcut. Okay, so when a is equal to 1, which in this case it is, you can use a shortcut. And let me show you what this shortcut is. So we're going to do a few examples where the a coefficient is 1, and then once it's not 1, then we're going to run into a couple of problems. But when a is 1, the shortcut is this. We want to write down our c term, which is 12, right? Now we want to list the factors of 12, and what we're looking for are going to be the factors of 12 that will add up to the b term. So we write down our 12. Now what are the factors of 12? Let's just write them down. After a while you could probably do this in your head fairly quickly, but 12 could be written as 12 times 1, or it could be written as 6 times 2, or 3 times 4. We also have negatives too. 12 could be written as negative 12 times negative 1, negative 6 times negative 2, and negative 3 times negative 4. Okay, so I believe that's all the factors. Now, what we're looking for is going to be the factors that will add up to the middle term. So 12 and 1, okay, they multiply to get 12, but they add up to get 13, right? And that's not what we're looking for. We're looking for 8. 6 and 2 add up to 8. So this is going to be part of our solution here. So this wouldn't work. Those add up to 7, negative 13, negative 8, and negative 7, right? So we're looking at this 6 and this 2 here. Now when we go to factor this, we're going to have a binomial times a binomial. And since our term here is x, this will be x and this will be x. Okay, because x times x will make x squared. And now what numbers would go here and here? Well, these two numbers here, this 6 and this 2. So we're going to have a positive 6 and a positive 2. So let's see, this is our solution now, x plus 6 times x plus 2. Fairly easy with this shortcut, right? If a is 1, you could just apply this shortcut here and go straight to our answer. So let's check our answer. X times x, we get x squared. 6 times x, we get 6x. And then x times 2, we get 2x. And then 6 times 2, we get 12. So if we combine like terms here, this is x squared plus 6x and 2x is 8x, and then plus 12. And that is indeed what we started with, right? So this is our solution. This is our factored form of x squared plus 8x plus 12, right? We have something times something else. Now, let's try this in number 2. So now in number 2, we have x squared minus 6x plus 8. Here, if you wanted to, it's a good habit to identify what your a, b, and your c are. The a is the coefficient of the x squared, which is 1. So what that means is we're going to be able to apply that shortcut. Now b is the coefficient of x, which is negative 6. And c is 8 here. So the term by itself. You could think about it as being the coefficient of x to the 0th power. But typically that's not written like that. So our constant term here is 8, and that's going to be c. So now when we go to factor this, remember what we want to do. We could apply the shortcut, which is we're going to look at c, which is 8 in this case. Now there's going to be another term for this. This is actually called the diagonal product, but I'll get to that for example number 4. So the number, with this one here, we have the number 8, and we want to list the factors of 8. So what we're doing is we're finding the numbers that will multiply together to get 8 that will add to the middle term. That simply comes from foiling. That's the reverse process. We're just kind of doing it in reverse. We know that we would combine those two middle terms, and then we would know those constant terms are multiplying to get our constant number. So this is the process in reverse, essentially. So factors of 8, well, there's 8 times 1, 2 times 4, and then don't forget the negatives, right? There's going to be negative 8 times negative 1, and then negative 2 times negative 4. Okay, these are all the factors. And if you're still, not comfortable doing this in your head, I would recommend doing this process, listing all the factors. Again, but once you're good, you don't need to do this anymore. So now we want to see what they add up to. And what we're looking for is that they're going to add up to b. Okay, we want them to add up to negative 6. So 8 and 1 will add up to 9. That's not what we want. 2 and 4 add up to a positive 6. That's close, but that's still not what we want, right? We want a negative 6. Negative 8 and negative 1, they add up to a negative 9. That's not what we want. And negative 2 plus a negative 4 add up to negative 6. These are going to be the two numbers that we want. This is going to be how we factor this trinomial here. So now we could go straight to our answer. We know, since this is a quadratic trinomial here, we're going to put our parentheses here. This will be x, and this will be x, because when those multiply together, we get x squared. And then our two numbers in here will be negative 2 and negative 4. And if we want to check our answer, we see x times x would be x squared. Negative 2 times x would be negative 2x. X times negative 4 would be negative 4x. And negative 2 times negative 4 would be a positive 8. And these two middle terms are going to combine. So we get x squared minus negative 2 and negative 4, we get negative 6x, and then plus 8. So that is indeed our answer here, x minus 2 times x minus 4. That's how we factor number 2 here. Okay, moving on, let's talk about example number 3. So same thing, just getting more practice doing this here. X squared minus 13x plus 36. First of all, if we want to factor this, I forgot to add in the directions here, but we're factoring 1 through 5, okay? 1 through 6, we're factoring those. So we want to factor this, and we're going to have a lot of different ways to factor it, but when we're given a quadratic trinomial, this method should be coming to mind. Take a look at the a, b, and the c. Could you identify a? A is 1, right? B is negative 13, and C is 36. Now, let me go ahead and write this down, because a lot of students think that the x will come with the a or the b or the c, but really a is the number in front of x squared, which in this case is 1. B is the number in front of the x term, x to the first, which is negative 13. and c is going to be our constant number, which is 36. So you see how a, b, and c, these are all just constant numbers. Now, this will be helpful for the future. You're going to need to be able to identify a, b, and c fairly quickly for many examples, so it's good to get used to that now. Now we want to go ahead and write down our c term, which is, again, this is actually called the diagonal product, and we want to try to find the factors of 36 that will sum to negative 13. Now, could you do this in your head? I mean, there's going to be a lot of factors of 36 if we try to sit here and list all of those. 9 and 4 will multiply to get 36, but we want a negative 13 here, so we want to be thinking, okay, maybe negative 9 times negative 4, and then we could go straight to our answer. But let me go ahead and list all the factors just for fun here. So 36 times 1, 18 times 2, 9 times 4, 12 times 3, 6 times 6, and is that everything? Is that all these factors? Yeah, that looks good. And then we also have all the negatives, right? Negative 36 times negative 1, negative 18 times negative 2, and negative 9 times negative 4, negative 12 times negative 3, and negative 6 times negative 6. Okay, so quite a few factors, right? We don't want to be doing this every single time we go to factor. So if you could think about these in your head, it's going to save you a lot of time. Now, of course, time isn't the goal, but if you're taking a test and you have to do these, this may not be the place you want to spend too much time on it. If you could have these, the simple math, if you have those simple math skills to do this in your head, go ahead and save yourself some time. But now, if you add this up, 37, we get 20, we get 13, 15, 12, negative 37, negative 20, and negative 13. That's what we're looking for, right? So negative 9 and negative 4. No other factors are going to work. There's only going to be one set of factors that work. You see, that's what we're looking for, right? The negative 13, and indeed negative 4 and negative 9, negative 9 and negative 4 will sum to negative 13. So we could go straight to our answer. We'll have an x minus 9 times x minus 4. And I always like to check my answer. I mean, x times x, we get x squared. Negative 9 times x is negative 9x. And x times negative 4 is negative 4x. And negative 9 times negative 4 is positive 36. So once we combine like terms in this statement here, we get x squared minus 13x plus 36. So this right here is definitely the factored form of this statement. So now let's go ahead and take a look at example number 4. So example 4 is where things are going to be changed up quite a bit here. We have 2x squared plus 9x plus 10. And I see that a lot of students actually forget the steps needed to actually factor this. A lot of students will try to do these in their head, and some are successful at it, and that's fine. But there's a particular method that will get you to the solution every single time, and this method is often forgotten. So what we do to begin is we find something called the diagonal product. Now, in the first 3 cases, we actually did have the diagonal product. The diagonal product happened to be C because A is 1. The diagonal product, let me write this down. So we have the diagonal product is equal to A times C. Now when A is 1, of course the diagonal product is just C. So that's what we were doing in the first 3 examples, is C was our diagonal product. So what we want to do here is take A times C, right? In this case, it is 2 times 10, which is equal to 20. Okay? Now, we want to repeat that step. Now, with our diagonal product, we want to find the factors of 20 that will sum to 9. Now, if you took a look at 10 and tried to come up with the factors of 10 that sum to 9, I don't think there are any, right? You get no, there's not any. 10 times 1, negative 10, negative 1, 5 and 2, negative 5, negative 2. These aren't going to work. Okay. And, you know, this is set up to, I mean, it's not, of course it's not going to work like that. But you need to pay attention to this a value here, which is 2. So now we have our diagonal product as being 20. We want to find the factors of 20 that will sum to 9. So we have 20 and 1. That doesn't work. We have 4 times 5. And those will sum to 9. So I'm just going to go ahead and stop. All right, you could keep going if you want. But once you find the factors you need, there's no need to keep any more. So 4 and 5, those sum to 9, right? Now, the next step is we want to go ahead and rewrite the middle, instead of saying middle, we want to go ahead and rewrite the b term. Middle could mean a lot of things depending upon the order that you write it, but we want to go ahead and rewrite the b term. So we're going to write the same statement, but instead of writing 9x, we're going to write 4x plus 5x. Now, in the previous case, we would go straight to our answer, right? We would say x plus 4, x plus 5. But if you try to do that here, you're going to see it's not going to work. First of all, if you did x plus 4 times x plus 5, you're going to get x squared for a leading term as opposed to 2x squared, right? So what we're going to want in our answer is a 2x times an x somewhere. And that's going to throw off the other terms too. And you could try to do this math in your head, but again, this is going to be the method that will get you to the solution here. So once we find the 4 and the 5, they add up to 9, right? We want to rewrite this 2x squared plus, instead of 9x, we're going to write it 4x plus 5x. That comes from these numbers here, and then we have a 10 right there as well. So you could see I didn't change the problem at all, right? I just kind of split things up. Like instead of writing 10, what if you wrote 5 plus 5? It means the same thing. Same thing with down here. Instead of writing 9x, I'm going to write 4x plus 5x. Now, that may seem kind of arbitrary, right? Like why not 8 and 1? And the reason is because when you want to go to factor this by grouping now, you know, only a particular set of numbers are going to work. Okay? And it's only going to be these that will multiply to that diagonal product and sum to the b term here. Now, a problem like this, in the previous video, we took a look at factoring by grouping, right? Now this turns into a factoring by grouping problem. So if you remember how to do that, we should have no problem here. So I'm going to go ahead and group the first two, and I'm going to go ahead and group the second two. So in this first group here, I see they have a factor of 2x in common with each other. And what remains here will be an x plus a 2. Right? So 2x times x would give me 2x squared, and 2x times 2 would give me the 4x. Now in the second group here, I see they have a factor of 5 in common. And now what remains is an x plus 2. Right? 5 times x, we get the 5x, and 5 times 2, we get the 10. So we have an x plus 2 here and an x plus 2 here. We could factor that out of the whole expression. And what remains is 2x plus 5 here. So that is our factored form now. So we have x plus 2 times 2x plus 5. All right? So if we go ahead and check our answer, we see that x times 2x would be 2x squared. 2 times 2x would be 4x. X times 5 would be 5x. And 2 times the 5 would be 10. And 2x squared plus, when we combine like terms, we get 2x squared plus 9x plus 10. And that was our original statement, right? So we definitely know that this is going to be the correct factored form here. Now let's go ahead and take a look at number 5. So for number 5, we have the same type of setup here. We have 3x squared plus 20x minus 7, and we're tasked with trying to factor this. So we see that a is equal to 3, b is equal to 20, and c is equal to negative 7. Now, don't get that from the order that this is written in. You want to get it from the fact that a is always the coefficient of the x squared, b is always the coefficient of x, and c is always the constant term. So we know a, b, and c. Now, the diagonal product is the first thing that we want to find here to factor this. We can't apply the shortcut, unfortunately, because a is not 1, it's 3. So the diagonal product is a times c, which in this case, a times c is equal to 3 times 7, which is 21. Now, once we get that diagonal product, we want to list the factors of 21 until until we see the sum would be 20. So let's see. Oh, you know what? Mistake. All right. 3 times negative 7, right? So 3 times negative 7, which is negative 21. All right, not positive. All right. So yeah, the sign is really important here. A is positive 3, C is negative 7. So when we do the 3 times negative 7, we get negative 21 for the diagonal product. Now the factors of negative 21 would be negative 21 times positive 1, or a positive 21 times negative 1. We also have 3 times negative 7, or negative 3 times positive 7. Now we're looking for the factors that will sum to a positive 20. So this would be negative 20 if we added those, and this here is 20 if we add these together. So those are the factors we want. So the next step was to split that b term into 21x and negative x. So I'm going to rewrite my statement, but I'm going to replace the 20x with positive 21x and negative x. And then I still have that negative 7 tacked on right here. And again, the reason we do this is so that factoring by grouping will work out correctly. Because there's a lot of ways to split up 20, but there's only going to be one way that will allow for the factoring by grouping to work. So now we see, I'm going to go ahead and group the first two together, and I'll group the second two together. So the first two have quite a bit in common. They have a factor of 3 in common, as well as a factor of x. And what remains would be x plus 7, right? If you do 3x times x plus 7, we should get that right there. And of course we do. Now I know I want an x plus 7 over here. So from the second group, I'm going to factor out a negative 1. And if you factor a negative 1 out of a negative x, you're left with a positive x. And if you factor a negative 1 out of negative 7, you're left with a positive 7, right? And again, if you distribute this negative 1 to x, we get negative x. If you distribute the negative 1 to positive 7, we get that negative 7. So we have x plus 7 and x plus 7. So we go ahead and write that down. And we have 3x minus 1 remaining. Okay, that's factoring out the x plus 7 and being left with the 3x minus 1. And this is the final factored form of 3x squared plus 20x minus 7. Now, and number 6 is x squared minus 49. So we have that a is equal to 1. Now b, what is b? What's the coefficient of the x term? We don't see any x to the first power, right? So you could think about the b as being 0 in this case, right? We have a 0x. And then c is equal to negative 49. Now let's see here. Since a is 1, that means we could apply our shortcut, right? It doesn't matter that this looks drastically different from 1, 2, and 3. We have an a, b, and a c, and we know a is 1. So let's try to factor this using the shortcut. Remember, to do that, we have negative 49 is our diagonal product. It's just going to be c. And now the factors of negative 49 that will sum to b. Let's see, we have negative 7 times positive 7. And that will do it, right? Negative 7 plus 7 will sum to 0. So I don't need to list any other factors. That's going to do it. So the factored form of x squared minus 49 will be x minus 7 times x plus 7. Now there's actually there's a formula. It's called the difference of two squares. But if you don't memorize this formula here, then you can just go ahead and factor the normal way. But difference of two squares, it says that if you have the difference of two squared terms, like in this case we have x squared minus 49, here the role of a is being played by x and the role of b is being played by 7, because 49 you could think about as being 7 squared, right? So the difference of 2 squared could be factored as a minus b times a plus b. And that's exactly what we got for our answer, right? X minus 7 times x plus 7. And that's what this formula here says. So you could memorize this formula if you'd like, or you could just remember that with this first type of factoring, our b term is 0. So that's going to cancel out the x. So let's go ahead and take a look at the last two examples here. With number 7, we have x squared minus 7x minus 18 is equal to 0. And the directions here are to solve. And we want to solve for x. That's the only variable we could solve for. So if we try to solve this using the typical methods where we may add 7x to one side, maybe add 18, divide by something, it's going to be very, very, very difficult to solve this problem. You'll have to stumble upon something called the quadratic equation, the quadratic formula, to be able to solve something like this, which is a little tricky to do. So the method here is to use factoring to our advantage. So let's see. So now, if we could obtain this, if we could obtain something like, if we know that a product, a times b, is equal to 0, then either a must be equal to 0 or b is equal to 0, right? We can't have two non-zero numbers multiply to get 0, right? One of these numbers has to be 0. So we're going to have to apply this logic here to be able to solve this type of problem. So when do we get a product between, when do we have a product? Essentially, like if you factor this, you're going to obtain a product. So the trick is to factor this, change this into a product between two things, and then use this logic here to determine, okay, one set of parentheses has to be 0, or the other set of parentheses has to be 0, because that's the only way two things could multiply to get 0. So to factor this, let's try to do this in our head now. The factors of negative 18 that will sum to negative 7. Well, if we have x minus 9 and x plus 2, negative 9 and positive 2 will will multiply to get negative 18, and negative 9 plus positive 2 will sum to get negative 7. So that looks like the correct factored form, and this is still equal to 0. So now we're going to apply this logic over here. In order for this product to equal 0, either the first piece, x minus 9, must equal 0, or x plus 2 must equal 0, right? There's no other way, right? If you have a times b equal to 0, then either a or b has to be 0. So either x minus 9 is 0, or x plus 2 is 0. So in this case, if x minus 9 was 0, then if you add 9 to both sides, we get x is equal to 9. If x plus 2 is equal to 0, subtracting 2 from both sides, you get x is equal to negative 2. So let's see if that works. If you plug 9 in, we get 81 minus 63 minus 18 equal to 0. That's a true statement. Or if you plug in negative 2, we get 4 plus 14, which is 18, minus 18, that's also 0. So in these quadratic trinomials, it is possible to obtain two answers, right? In our linear equations, we'd only be obtaining a single answer. And these two answers really have to do with the properties of parabolas crossing the x-axis. So if we think about our Cartesian plane, and we think about our x-axis. If we solve something, we have this object here equal to 0. Now parabolas could look like U-shapes. So they may look something like this. All right. And so where this parabola is crossing the x-axis is our two solutions, 1 and 2. Whereas if we have a line, if we take a line like this, it's only possible for the line to cross at one particular point. So we obtain single answers for lines. But now I should mention that parabolas could appear many places in the Cartesian plane, so it is possible to obtain a single answer. In some cases, you end up with a parabola that just sits with one point on the x-axis, which would be the single solution to a particular equation. Other parabolas don't have to cross it at all, and in some cases there's no solutions. But this is why it's possible, just because of the properties of these parabolas, why we're obtaining these two solutions here. So that's number 7. Now let's take a look at number 8. So number 8 is a fairly difficult example. It could be a stumbling block for many students. We have 2x squared plus 5 is equal to 11x. And again, the directions here, we want to be able to solve for x. So first of all, we take a look at this here, and we see an x squared term, we see an x to the first power, and we see a constant term. So we want to be thinking about these quadratic trinomials. Now we also want to be thinking about that logic we use, that logic where if you have a times b equal to 0, then a equals 0 or b equals 0. This has a name. It's called the zero product property. Now, we want to be thinking about this property when we see these quadratic trinomials, if we're trying to solve for x here. So, we could only use this property if we have one side of the equation equal to 0. So, in order to use this, we're going to have to take a look at our equation and somehow get one of the sides equal to 0. So you could either move the 2x squared to the other side by subtracting it and subtracting the 5, or you could subtract the 11x and get it over here to this side. I would recommend moving the 11x. It's generally a good idea to keep your highest degree variable coefficient positive. It's just going to be a little bit easier to work with than if it was negative. So I'm going to go ahead and subtract 11x from both sides to begin with. So we obtain an equivalent equation that says 2x squared minus 11x plus 5 is equal to 0. So now we have this nice equation equal to 0, and we know how to factor this. We have to look at numbers 4 and number 5 to know how to factor something like this. And first step to factor something like this, and keep in mind why we're factoring. We're trying to get this product here. So if you do the typical equation solving at this point without factoring, you're going to run into a lot of trouble, and it's going to be almost impossible, again, unless you stumble across the quadratic formula, which is not easy to stumble upon without hours of work, really. So our diagonal product is a times c, which in this case would be 2 times 5, which is equal to 10, right? Now we want to take this diagonal product and we want to find the factors of 10 that will sum to negative 11. In this case, negative 10 times negative 1 will equal a positive 10, and they also sum to negative 11. So these are the factors that I want. Now I'm going to rewrite the statement, 2x squared, but instead of writing negative 11x, I'm going to write negative 10x and negative x. I'm saying negative 1x, but you don't need to put the 1, right? Just negative x, and then plus 5. And this is still equal to 0. Okay. Now I'm going to go ahead and do factoring by grouping at this point. So I'm going to group the first two, and I'm going to group the second two. I see I have a 2x in common for the first group, and what is left behind is x minus 5. Now I'm going to want an x minus 5 over here, so I want this to be positive and I want this to be negative. So you could do that by factoring out a negative 1 to change the sign here. So if you factor negative 1 out of negative x, you get a positive x. And if you factor negative 1 out of positive 5, you get negative 5. And this is still equal to 0. Now, we have x minus 5 and an x minus 5, so we could factor that out of the whole expression. And what remains is the 2x and the negative 1 here. So x minus 5 times 2x minus 1 is equal to 0. Now, lastly, what we have is x minus 5 times 2x minus 1 equal to 0. We're going to apply the zero product property. So either x minus 5 is equal to 0, in which case we could just do the math quickly. If you add 5 to both sides, we get x is equal to positive 5. Or 2x minus 1 is equal to 0. So we want to write two equations here, right? Now if we have 2x minus 1 equal to 0, then if you add 1 to both sides, we get 2x is equal to 1. And then if you divide by 2, solving for that x, we get x is equal to 1/2. So x is equal to 5 and x is equal to 1/2. Those are going to be the two answers, meaning this parabola, we're not going to talk about parabolas in this video, but this parabola is going to cross the x-axis at x is equal to 5 and x is equal to 1/2. If you plug in 5 here, we see we get 50 plus 5 is equal to 55, so that certainly works. And if you plug in 1/2, we get 1/2 plus 5 is 5.5, which is equal to 11 times a half, which is 5.5. So these two solutions do certainly check out. So a lot of examples in this video. If you're confused about any of these, I recommend going back and taking a look at a few of them. But I hope you enjoyed this video, and I'll see you in the next one.